Understanding your home's electrical system, a beginner's guide. Hey everyone, welcome to Weekend Workshop Pro. Today we're kicking off our electrical basics series with something every homeowner should understand: how your home's electrical system works. Before we dive in, remember, electrical work can be dangerous. Always consult a licensed electrician for complex repairs, or if you're unsure about anything. Let's break down your home's electrical system into 5 main components. First, we have what's called the service drop, those wires you see coming from the utility pole to your house. This is where your home gets its power. Next is your electric meter. Think of it as your home's speedometer for electricity consumption. This is where the power company measures how much electricity you're using. Now for the brain of your electrical system, the main service panel or breaker box. This is where the incoming power is distributed throughout your house. Inside this panel you'll find the main breaker, individual circuit breakers, different circuits for different areas of your home. From your service panel, electricity travels through what we call branch circuits. These are like the branches of a tree, carrying power to different areas of your home. Typically, you'll have circuits for kitchen appliances, bedroom outlets, lighting, heavy-duty appliances like your AC. Finally, we have the endpoints, your outlets and fixtures. These are what you actually use day to day. Let me show you something cool about outlets. Understanding these basics is crucial because it helps you communicate better with electricians. You can troubleshoot simple problems. You'll know when something isn't right. 4. It can help prevent electrical accidents. Remember, this video is for educational purposes only, always. Turn off power at the breaker before any electrical work. Use proper safety equipment. Check local codes. Know when to call a pro. In our next video, we'll look at essential safety equipment every DIYer needs. Hit subscribe and the notification bell so you don't miss it. Drop a comment below with any questions, and let me know what electrical topics you'd like to see covered. Thanks for watching and stay safe. Essential safety gear for DIY electrical work. Hey dyers! Safety isn't just a suggestion when working with electricity, it's absolutely essential. In today's video, I'm going to show you the must-have safety equipment that could literally save your life. Let's get started. Before we dive in, here's a scary fact. Over 30,000 non-fatal electrical shock accidents happen at home each year. Most could have been prevented with proper safety equipment. Don't become a statistic. Let's make sure you're properly protected. First up, eye protection. Let me show you what to look for. ANSI Z87 1 certification mark. Side shields for complete protection. Anti-fog coating is a plus. Demonstrate proper fit and usage. Pro tip, keep a spare pair handy for when you need a helper. Next, your hands need protection. Here's what I recommend. Class 00 rubber insulating gloves. Always check for holes or tears before use. Demonstrate the air test for checking gloves. Leather protector gloves for extra durability. Remember, replace these every 6 months or immediately if damaged. This is your lifeline. Non-contact voltage tester. Multimeter for detailed testing. Demonstrate testing process on both. Critical tip, always test your tester on a known live circuit first. Your feet need protection too. Rubber-soled work boots. No exposed metal parts. Must be completely dry. Warning, never work in wet conditions or with wet footwear. Let's talk tools. Look for the 1000 V rating. Double insulated symbol. No exposed metal parts. Show comparison between regular and insulated tools. Remember, damaged insulation means replace immediately. Always have these nearby. First aid kit. Fire extinguisher, Class C rated. Emergency contact numbers. Phone within reach. There you have it. The essential safety equipment every DIYer needs. Remember, this gear is useless if you don't use it consistently. No project is worth risking your life over. Hit that subscribe button and the notification bell to stay safe with more DIY electrical tips. Drop a comment below with your safety questions. Understanding and safely using your circuit breaker panel. Hey everyone! Welcome back to Weekend Workshop Pro. In this video, we're diving into something every homeowner needs to understand: your circuit breaker panel. By the end of this video, you'll know exactly how your panel works and how to safely navigate it. Your circuit breaker panel might seem intimidating at first glance, but it's actually a crucial safety system designed to protect your home and family. Today, we're going to explore how your circuit breaker panel works and how to use it safely and effectively. Think of your circuit breaker panel as your home's electrical command center. Just as your heart distributes blood throughout your body, your circuit breaker panel distributes electricity throughout your home. Located usually in a basement, garage, or utility room, this gray metal box contains multiple switches that control the flow of electricity to different areas of your house. At the top of your panel, you'll find the main breaker, the master switch that controls all power to your home. It's typically larger than the other breakers and might be rated at 100, 200, or even 400 amps, depending on your home's size and electrical needs. When you flip this switch, you're essentially turning off all electricity to your house, similar to turning off the main water valve for your plumbing system. Below the main breaker, you'll see rows of smaller switches. Each of these controls a specific area or set of outlets in your home. These breakers are your electrical system's guardians, designed to trip, switch off, when they detect a problem, such as too much power being drawn through the circuit, overload, a short circuit, a ground fault. Just as a pressure relief valve prevents a pipe from bursting, these breakers prevent electrical fires by cutting power when they sense danger. Your panel should have a directory that maps each breaker to its corresponding area. For example, Breaker 1, kitchen outlets. Breaker 2, living room lights. Breaker 3, upstairs bathroom. If your panel isn't labeled clearly, consider creating a new directory. You can identify which breaker controls what by having someone help you. Turn off one breaker at a time and note which lights or outlets stop working. 15-amp breakers usually control lighting circuits and general use outlets. 20-amp breakers, often used for kitchen outlets and other high-draw areas. 30-amp breakers, typically reserved for large appliances like electric dryers. 40-amp or 50-amp breakers usually control electric ranges or HVAC systems. If a circuit breaker trips, it's telling you something important about your electrical usage. Here's what to do. Unplug some devices from the affected circuit. Locate the tripped breaker. It will be in the middle position, not fully on or off. 3. Push it fully to the off position. Then firmly push it to the on position. Remember, if a breaker keeps tripping, it's warning you about a potential problem. Don't ignore it. This is when you should consult an electrician. Always remember these essential safety tips. Never force a breaker that resists being reset. Keep the area around your panel clear and accessible. 3. Never replace a breaker with one of a higher amperage rating. If you smell burning or see discoloration around breakers, contact an electrician immediately. Modern homes often have specialized breakers for added safety. GFCI, ground fault circuit interrupter, breakers protect against shock in wet areas. AFCI, arc fault circuit interrupter breakers protect against electrical fires from arcing. Dual function breakers combine both GFCI and AFCI protection. While understanding your panel is important, some tasks should be left to licensed electricians. Adding new circuits. Replacing breakers. Upgrading your electrical service. Investigating frequent breaker trips. Dealing with burning smells or hot breakers. Just as you schedule regular maintenance for your car, your electrical panel benefits from periodic professional inspections. An electrician can check for loose connections. Test breaker function. Identify potential issues before they become problems. Ensure your panel meets current safety codes. Your circuit breaker panel is more than just a box of switches. It's an essential safety system that protects your home 24 hours a day. By understanding how it works and treating it with respect, you can help ensure your home's electrical system remains safe and reliable for years to come. There you have it. You now understand the basics of your circuit breaker panel. Remember to like and subscribe for more DIY electrical guides. Drop a comment below if you have any questions. How to safely and effectively use a multimeter. A multimeter is like having a whole electrical laboratory in the palm of your hand. This versatile instrument can measure voltage, current, and resistance, making it an invaluable tool for both professionals and hobbyists. However, just as a microscope requires proper technique to yield accurate results, a multimeter demands careful handling and understanding to ensure both accurate measurements and personal safety. Before we dive into measurements, let's familiarize ourselves with the parts of a typical multimeter. Imagine your multimeter as a sophisticated translator that speaks the language of electricity. The face of your multimeter features several key elements. Asterisk, asterisk. The display. Asterisk, asterisk. This digital window shows your measurements, much like the screen of a calculator. Modern digital multimeters typically show not just numbers, but also helpful indicators like battery life and measurement units. The selection dial. Think of this as your multimeter's main control center. It lets you choose what type of electrical property you want to measure, similar to how you might select different modes on a camera. The dial typically includes settings for voltage V, both AC tilde and DC, current A, resistance omega, continuity, usually marked with a sound wave symbol, capacitance F, temperature degree C or degree F, asterisk asterisk, the ports asterisk asterisk. At the bottom of your multimeter, you'll find several ports for connecting your test leads. These are like the different inputs on a stereo system, each serving a specific purpose. Common port. The black lead always goes here. VOMA port, for voltage, resistance, and small current measurements. 10. A port, for measuring larger currents. Before making any measurements, always follow these crucial safety steps, much like checking your safety gear before scuba diving. Inspect your equipment. Examine the test leads for any damage to the insulation. Check that the probe tips are clean and undamaged. Ensure your multimeter's case is intact with no cracks. Verify that the battery is fresh to ensure accurate readings. Set up your workspace. Choose a dry, well-lit area. Keep your workspace clean and organized. Ensure you have stable footing and both hands free. Remove any metallic jewelry or watches. 3. Follow the voltage rating. Never exceed your multimeter's maximum voltage rating. Use only CAT-rated multimeters for mains electricity. Understand that different CAT ratings indicate different safety levels. Think of voltage measurement like checking water pressure in a pipe, but you must do it without breaking the circuit. Set your multimeter to the appropriate voltage setting. Choose AC voltage tilde for wall outlets and most household appliances. Select DC voltage for batteries and most electronic devices. Always start with the highest range if you're unsure of the voltage. 2. Connect your leads properly. Black lead to COM. Red lead to VOMA. Never measure voltage with leads in the current ports. 3. Asterisk asterisk, make contact with the circuit asterisk asterisk. Touch the black probe to the reference point, usually ground or negative. Touch the red probe to the point where you want to measure voltage. Keep your hands behind the probe guards. When measuring resistance, think of it as checking how difficult it is for electricity to flow through a component. Prepare the circuit. Always turn off power to the circuit. Discharge any capacitors. Isolate the component if possible. Set up your multimeter. Select the resistance, omega function. Choose an appropriate range. Zero your meter if necessary. 3. Asterisk asterisk, take the measurement, asterisk asterisk. Connect the probes across the component. Ensure good contact with clean surfaces. Wait for the reading to stabilize. Current measurement requires special care because the multimeter becomes part of the circuit. Prepare carefully. Turn off the circuit power. Break the circuit where you want to measure. Select the appropriate current range and port. 2. Asterisk asterisk, connect in series, asterisk asterisk. Place the multimeter in line with the circuit. Use the 10A port for unknown or large currents. Never try to measure current in parallel. 3. Asterisk, asterisk. Take precautions. Asterisk, asterisk. Start with the highest range. Keep measurements brief to avoid heating. Never switch ranges while measuring. The one-hand rule. When possible, use only one hand while making measurements. This reduces the risk of creating a path for current through your heart. Keep your other hand either at your side or in your pocket. Proper range selection. Always start with the highest range and work your way down. This is like using a telescope. You start with the lowest magnification to find your target, then increase magnification for detail. 3. Understanding your limitations. Know when to call a professional. Just as you wouldn't perform surgery on yourself, there are electrical measurements that should be left to qualified electricians. If your readings are unstable, check for loose connections. Verify the battery condition. Ensure you're using the correct range. Look for sources of electrical interference. Watch for common causes of incorrect measurements. Wrong function selected. Incorrect range. Poor probe contact. Interference from nearby electrical fields. 1. Regular maintenance. Clean the probes with alcohol and a clean cloth. Check batteries monthly. Store in a cool, dry place. Keep the original case for protection. 2. Asterisk, asterisk, calibration, asterisk, asterisk. Consider annual calibration for critical measurements. Verify accuracy against known references. Keep a log of calibration dates. Using a multimeter safely is about more than just following rules. It's about developing good habits and understanding why each safety measure matters. Like any skilled trade, electrical measurement requires both knowledge and practice. Start with simple measurements, build your confidence gradually, and always prioritize safety over convenience. Remember, the most important measurement you'll ever make is the one that gets you home safely at the end of the day. If you ever feel uncertain about a measurement or encounter something unexpected, stop and consult a professional. Your multimeter is a powerful tool, but it's also a safety device. Treat it with respect, and it will serve you well for years to come. And that's it for this video. Like and subscribe for more. A beginner's guide to reading electrical diagrams. Imagine you're looking at a map of a city you've never visited. Just as a city map uses symbols to show streets, parks, and buildings, electrical diagrams use standardized symbols to represent different components and their connections. Today, we'll decode these electrical maps together, making them as familiar as reading your favorite book. Every language has its alphabet, and electrical diagrams are no different. Instead of letters, we use symbols to represent different components. Let's start by understanding these basic building blocks. Think of power sources as the starting point of our electrical journey, like the source of a river. In diagrams, you'll see them represented in several ways. A battery appears as a series of long and short parallel lines. AC power sources show up as a sine wave symbol, or the letters AC. DC power sources are marked with straight lines and often labeled with DC. Solar cells have their own distinct symbol, often looking like a circle with rays. These are like the common words in our electrical language. Imagine resistors as speed bumps in the electrical flow. They're shown as either a zigzag line, a rectangular box with a value written inside. The number next to them tells us their resistance in ohms, omega. Think of capacitors as tiny electrical storage tanks. They appear as two parallel lines for basic capacitors, one curved line for polarized capacitors. Always note the positive and negative markings on polarized capacitors. Picture inductors as traffic circles that help control electrical flow. They're drawn as a series of loops or curves, sometimes with an iron core shown as parallel lines beside them. These are the traffic lights of our electrical system. Switches show up as lines with a gap and sometimes an arrow showing movement. Relays appear as switches with additional control circuitry. Just as roads connect different parts of a city, wires connect components in a circuit. Solid lines show electrical connections. Dots at intersections mean wires are connected. Crossing lines without dots mean wires pass over each other without connecting. Dashed lines might represent alternative connections or optional paths. Think of grounds as the electrical system's foundation. Earth ground looks like 3 horizontal lines getting progressively shorter. Chassis ground appears as a single diagonal line. Signal ground might show up as a triangle. These are like street maps showing the logical flow. Components are represented by their symbols. Physical layout isn't important. Focus is on electrical connections and function. Usually easier to understand the circuit's operation. Think of these as satellite views showing actual physical layout. More realistic representation of component placement. Shows actual wire routing. Includes connector types and wire colors. Useful for installation and maintenance. These are like neighborhood maps showing general areas. Simplified boxes represent major circuit sections. Arrows show signal or power flow. Good for understanding overall system function. Less detail than schematics. Begin your diagram reading journey at the power source. Follow the main power lines. Note voltage levels. Identify major power distribution paths. Look for power conversion stages. Trace signals like following a river from source to sea. Start at inputs. Follow through processing stages. A beginner's guide to reading electrical diagrams. End at outputs. Note signal modifications along the way. Group components like clustering buildings in a neighborhood. Look for common circuit patterns. Identify familiar subsystems. Understand block interactions. Note feedback loops. These are like the power plants of our electrical city. Transformer symbols for voltage changes. Rectifier diodes for AC to DC conversion. Filter capacitors for smoothing. Voltage regulators for stable output. Think of these as signal boosters. Input coupling capacitors. Biasing resistors. Feedback networks. Output stages. These are the decision makers in our circuit. Gates shown as distinctive shapes. Flip-flops for memory. Clock generators for timing. Bus connections for data. Before diving into the diagram, read any accompanying notes. Check the legend for special symbols. Review revision history. Note any warning or caution statements. As you study the diagram, use highlighters for different circuit paths. Make notes about voltage levels. Circle test points. Write questions for later investigation. Modern resources can help. Use zoom features for detail work. Take advantage of layers in digital drawings. Search for standard symbols online. Consider simulation software. When dealing with large systems, use page references and indexes. Make a simplified overview. Track connections between pages. Keep notes on interconnections. Reading electrical diagrams is a skill that grows with practice. Start with simple circuits and gradually work up to more complex systems. Remember that every expert started as a beginner, and every diagram tells a story. You're just learning to read its language. Keep this guide handy, and soon you'll be navigating electrical diagrams with the confidence of a seasoned professional. Remember, understanding electrical diagrams is not just about recognizing symbols. It's about seeing how components work together to create functioning systems. Take your time, build your knowledge gradually, and don't hesitate to ask questions when needed. This brings us to the end of this video. Like and subscribe.